Imagine that I teach you something today. Maybe I explain how inflation works, or how to identify a logical fallacy, or how to calculate compound interest. You listen, it makes sense. At the end, I ask you a question about it, and you give me the right answer. Have you learned it? That sounds like a very simple question, but I'm not sure it is. Suppose I ask you the same question tomorrow, and you can't answer it. Did you learn it yesterday and then forget it? Or did you never really learn it in the first place? Now, suppose you remember it perfectly tomorrow. I change the example slightly, though, and suddenly you don't know what to do. Did you learn it? Or suppose you can give me the definition. You can repeat the example I gave you. You can even get an A on the test. But 6 months later, when you encounter the same idea in a completely different situation, you don't recognize it. Again, did you actually learn it? I think these questions reveal a problem with the way we ordinarily use the word learning. We use one word to describe several very different things. And if we don't distinguish between them, it's surprisingly easy for teachers and students to mistake the appearance of learning for the real thing. So, I want to begin this series with what seems like the most basic educational question of all. What does it actually mean to learn something? I think we need to separate at least four things that are commonly treated as though they're interchangeable: exposure, remembering, performance, and learning. They're related, but they're not the same. Let's start with exposure. Suppose you're sitting in a lecture about the causes of the Great Depression. You've heard about the stock market crash, bank failures, declining consumption, monetary contraction, international trade. You followed the lecture. Maybe you even found it interesting. You've certainly been exposed to the information. But exposure tells us very little about what you can subsequently do with it. This seems obvious when we say it explicitly, and yet a surprising amount of education is organized around exposure. We covered Chapter 4. Students watched the video, I explained the formula, they completed the reading. Those statements tell us what happened instructionally, they don't necessarily tell us what happened cognitively. There's a substantial difference between information passing through someone's environment and that information producing a durable change in what the person can subsequently do. That's our first distinction. Exposure is an opportunity for learning. It is not evidence that learning occurred. Now, move one step further. Suppose tomorrow I ask, what are some causes of the Great Depression? And you remember several of them. That's more significant. Something survived. You didn't merely encounter the information. You retained at least part of it. Memory is obviously essential to learning. If nothing persists, it's difficult to claim that much learning has occurred. But memory creates another problem, because human beings can remember things they don't understand particularly well. Think about something many of us experienced in school. You memorize a formula. You can reproduce it perfectly, but you have only a vague idea what the variables actually represent. Or you memorize a definition. Photosynthesis is the process by which plants convert light energy into chemical energy. Fine. Now I ask you to explain what's actually happening without using the memorized sentence. That's harder. Or I give you an unfamiliar plant growing under unusual lighting conditions and ask you to predict what will happen. Now we're testing something different. The memorized statement may have survived perfectly while the underlying concept remains poorly developed. This is why remembering matters enormously, but remembering alone can't be our definition of learning. A person can possess a piece of information without possessing much ability to use it. And this brings us to the third category, performance. This one is particularly important in schools. Imagine that I'm teaching you how to solve a particular kind of equation. I demonstrate one. Then we solve another one together. Then I give you a third. It's almost identical to the first two. You solve it correctly. Excellent. But what exactly have I demonstrated? Certainly something. You performed successfully, but consider how much support was built into that performance. You had just watched me do it. The relevant strategy was already active in your working memory. The new problem closely resembled the examples. You knew exactly what kind of problem you were supposed to be solving. You were in the same room, working on the same topic, probably using the same notation. Then the next day, I put the same underlying mathematics inside a word problem. and you don't recognize it. That's educationally revealing. The original performance was real, you really did solve the problem, but the performance may have depended heavily on the conditions surrounding it. Change the conditions, and the competence disappears. This is one reason I think educational assessment can become misleading. We often measure whether someone can succeed right now under the conditions we've created, and then infer that the person has learned whatever produced that performance. Sometimes that's justified, sometimes it isn't. A successful performance is evidence, but one successful performance isn't necessarily strong evidence of learning. This is where I think we need a stronger concept. The one I keep returning to is reliability. If someone has genuinely learned something, then there should be some reasonable range of conditions under which that learning continues to work. Not every imaginable condition. That's important. I'm not proposing an impossible standard where learning only counts if a person can remember and apply something perfectly forever in every situation. Human cognition doesn't work that way. Instead, the question is, how reliably can this person succeed when the circumstances vary within the reasonable boundaries of what we claim they have learned? That shift matters because now we're not simply asking, did the student get the answer right? We're asking, what does the successful answer allow us to predict about future successful answers? That, to me, is much closer to the heart of learning. The educated framework treats epistemic reliability as a central goal. Strategies should succeed across appropriate environments, rather than merely producing episodic performance. And I think this gives us a useful way of thinking about education more generally. Learning is a change that makes future successful thinking or action more reliably possible. Consider driving. Imagine someone has studied the driver's handbook extensively. They can tell you the legal blood alcohol limit. They know what a flashing red signal means. They can explain right-of-way rules at a four-way stop. That's knowledge in one sense. Now put them behind the wheel. A car ahead brakes suddenly. A pedestrian approaches a crosswalk. Traffic is merging from the right. It's raining. Another driver does something slightly irrational, which of course is a completely hypothetical event that never occurs on an actual freeway. Now, we discover what the driver can do with what they know. And importantly, an experienced driver usually doesn't consciously recite rules while driving. They perceive situations. They recognize patterns. They anticipate. They adjust. They can encounter a configuration of traffic they've never seen before and still respond appropriately. That last part matters, because genuine learning doesn't merely reproduce the past. It equips us to handle some amount of novelty. The technical idea lurking here is transfer. Transfer occurs when learning developed in one situation can be used in another. And transfer gives us one of our strongest tests of learning. Suppose a student learns about supply and demand using the price of hamburgers. They understand the graph. They can explain what happens when demand increases. Now change hamburgers to housing, or concert tickets, or labor, or foreign currency, or something messy where several variables change at once. What happens? If the student can recognize the underlying structure despite changes in the surface features, something important has happened. They don't merely remember the hamburger example. They possess a concept that travels. That's a much more powerful form of knowledge. The framework we've developed explicitly treats transfer as the ultimate test of learning. Instruction should eventually produce successful use in new contexts, including situations where the original scaffolds are no longer present. And that suggests a useful continuum. At one end, I can repeat exactly what you showed me. Then I can solve something very similar. Then something moderately different. Eventually, perhaps, I can recognize the same underlying principle somewhere I was never explicitly told to look for it. The farther that competence can travel within reasonable boundaries, the stronger the evidence that I've learned something meaningful. At this point, though, reliability can sound suspiciously like perfection. If genuine learning has to survive different contexts and persist over time, are we saying that forgetting means you never learned? No. And I think this qualification is essential. Learning isn't binary. It isn't a switch that moves permanently from off to on. Memory changes, skills decay, context matters, Stress matters. Attention matters. Prior knowledge matters. The amount of time since practice matters. Even experts make mistakes, so reliability should be understood probabilistically. Learning changes the likelihood of successful performance. Before instruction, perhaps I can solve a particular class of problems 10% of the time. After effective learning, maybe it's 80%. With continued practice and feedback, perhaps 95%. The goal isn't infallibility, it's a sufficiently durable change in the probability of successful performance. And sufficiently depends on what we're talking about. We tolerate occasional mistakes in conversational Spanish. We tolerate far fewer mistakes from someone performing surgery. Different forms of knowledge require different thresholds of reliability. This is one reason I resist simple definitions of learning. What counts as successful learning depends partly on the environment in which that knowledge is expected to operate. There's another complication. Not all learning looks the same. Sometimes learning means being able to state something. The Earth orbits the Sun. The Battle of Gettysburg occurred in 1863. Water freezes at 0 degrees Celsius under standard atmospheric pressure. These are propositions, but other knowledge is much harder to state explicitly. Think about recognizing that someone is being sarcastic, or knowing when bread dough has been kneaded enough, or hearing that a musician is slightly out of tune, or recognizing that a student's argument doesn't quite work even before you've identified exactly what is wrong with it. People can become remarkably reliable at these things without being able to articulate a complete rule system explaining how they're doing it. Michael Polanyi famously described this general phenomenon as tacit knowledge, the idea that human beings can know more than they can fully tell. Our broader epistemological framework deliberately includes this kind of tacit skill alongside explicit knowledge. And this complicates assessment, because if I ask an expert to explain everything they know, their verbal explanation may actually underrepresent their expertise. They may know it in performance. They may see distinctions a novice literally doesn't notice. They may reliably make good judgments while struggling to give you a complete algorithm for producing those judgments. So, reliable learning can't mean merely being able to explain everything verbally. Sometimes explanation is evidence of understanding. Sometimes performance is stronger evidence. And ideally, we want both when the domain permits it. This also changes how I think about instruction. In the learning model I've developed, I picture students beginning from a point of current understanding and moving toward the ideal use of a new strategy. Between those 2 points is uncertainty. That's where much of learning occurs. The model draws on Vygotsky's zone of proximal development, the space between what someone can currently do independently and what they can accomplish with appropriate support. That word independently becomes extremely important. Suppose a student can write a strong analytical paragraph when I give them a sentence starter, an evidence organizer, a model paragraph, a checklist, and continuous teacher feedback. That's good. Those supports may be exactly what the student needs right now. But if the student can only produce the paragraph when all of those supports are present, we shouldn't confuse supported performance with independent mastery. The scaffold is doing some of the cognitive work. The goal isn't to remove the scaffold immediately. That would misunderstand the ZPD. The goal is to use the scaffold to make successful thinking possible, and then gradually transfer responsibility to the learner. The synthesis of my educational framework describes the ZPD as diagnostic, dynamic, and temporary. Supports are introduced deliberately and then faded as reliability develops. That's a crucial distinction. Help is not evidence that learning failed. Sometimes help is precisely what makes learning possible, but successful instruction eventually changes what the learner can do when that particular help is gone. Although even that gets complicated, because what does independently really mean? Suppose I use a calculator. Do I no longer know mathematics? If I use a dictionary, do I no longer know how to write? If a pilot uses instruments, is the pilot's competence somehow less authentic? If a historian consults archives, databases, maps, and other historians, Are those external resources evidence that the historian doesn't actually know history? Clearly not. Human knowledge has always depended partly on tools. Writing itself is a cognitive technology. So are diagrams, maps, calendars, libraries, calculators, computers, and increasingly, artificial intelligence. This means we need to distinguish between two very different kinds of support. One support substitutes for a competence we claim the learner possesses. Another support is legitimately part of the competence itself. If I claim that I can multiply 17 by 23 mentally, reaching for a calculator changes the claim. But if I claim that I can prepare an accurate financial analysis, using a spreadsheet may be part of competent professional practice. That's not a minor distinction. It means knowledge isn't always located entirely inside one person's head. Our framework incorporates this idea through extended and distributed cognition. Tools, artifacts, practices, and other people can form legitimate parts of reliable knowing. So the question isn't simply, can you do it without help? The better question is, can you reliably accomplish the relevant task under the conditions in which competent people are actually expected to accomplish it? That's a much more demanding question, but it's also a much more realistic one. Now, return to school. A student attends a lesson. Exposure. They recognize the information on a worksheet. Familiarity. They remember it overnight. Retention. They answer a familiar question correctly. Performance. They pass the test. Achievement. All of those things matter, but none by itself necessarily demonstrates the kind of reliable learning we've been talking about. This helps explain a phenomenon teachers see constantly. Students can appear to know something very well during a unit and then seem to have never encountered it 3 months later. Or they can perform beautifully when the problem is labeled. Today, we're solving quadratic equations and struggle when the same mathematics appears without the label. Or they can explain a concept in a classroom discussion but fail to recognize it operating in ordinary life. This doesn't necessarily mean the instruction was worthless. It means learning has degrees of durability and degrees of transfer. And if our goal is reliable learning, then instructional design has to anticipate that. Retrieval matters because learners need practice bringing knowledge back rather than merely seeing it again. Spacing matters because knowledge needs to survive time. Interleaving matters because learners need to distinguish among problems rather than being told in advance which strategy to use. Variation matters because concepts need to survive changes in surface appearance. Feedback matters because successful learning requires correction, not merely repetition. And metacognition matters because eventually learners need to recognize for themselves when their understanding is failing. These practices recur throughout the educated framework precisely because the goal is not simply successful performance during instruction. The goal is knowledge that remains usable afterward. So imagine two students. Student A earns a 95% on Friday's exam. Student B earns an 82. 3 months later, we give them another assessment. Not the same questions. New questions testing the same underlying ideas. Student A scores 60. Student B scores 80. Who learned more? That's not as easy to answer as it initially appears. Student A unquestionably performed better on the original assessment, and perhaps that performance mattered, but student B's knowledge appears to have become more durable. Now change the assessment again. Give them a real-world problem requiring them to decide which ideas from the course are relevant. Student A doesn't recognize the connection. Student B does. The question becomes even more complicated. What exactly was the original grade measuring? This doesn't mean grades are meaningless. It means assessments are samples. We observe performance under one set of conditions and use it to infer something about an underlying competence we can't observe directly. That's what makes assessment difficult. Learning itself is invisible. We see its consequences, and we infer the rest. This brings me to the question I think is most useful. When we say someone understands something, what should that understanding buy them? I would propose several things. It should allow them to retrieve important knowledge after some passage of time. It should allow them to explain important relationships rather than merely repeat language. It should help them distinguish examples from non-examples. It should allow them to recognize the idea when its surface appearance changes. It should allow some degree of prediction. It should allow some degree of application. It should help them detect when their existing understanding no longer works. And ideally, it should allow them to revise what they know when new evidence requires it. Notice that this is a much richer conception of understanding than can answer questions about the material. Understanding becomes generative. It gives you something you didn't have before. It changes what you can notice, what you can predict, what you can explain, what you can do, and perhaps most importantly, what you can learn next. This may sound like an abstract philosophical distinction, but it changes almost everything downstream. If learning means exposure, then teaching is largely about presenting information. If learning means short-term performance, then teaching is largely about getting students through the immediate task. If learning means remembering, then teaching emphasizes retention. But if learning means developing reliable, transferable competence, then teaching becomes something larger. Now we have to ask, will this knowledge survive? Can the learner retrieve it? Can they recognize when it applies? Can they use it when the context changes? Can they detect errors? Can they revise? Can they operate when some of the original supports disappear? And can they intelligently use the tools and people that legitimately belong to the domain? Those are harder standards, but they're also closer to what we actually mean when we say education should prepare someone to think. So, what does it actually mean to learn something? I don't think it means merely having encountered it. I don't think it means simply remembering it. And I don't think one successful performance is enough. Learning is better understood as a durable change in what a person can reliably do with knowledge. The word reliably matters because one correct answer can be accidental, heavily scaffolded, or tied to a very specific context. The word do matters because knowledge should alter our capacity to think, judge, explain, predict, recognize, or act. And the word durable matters because learning has to survive at least some distance from the moment of instruction. But none of those standards requires perfection. Reliability is always relative to a task, an environment, and a reasonable range of conditions. That's the epistemological premise I want to carry through this series. Because before we argue about teaching methods, grading systems, motivation, technology, artificial intelligence, or what schools ought to become, we need some conception of the thing all of those systems are supposedly trying to produce. And I think that conception should be demanding. If education is doing something meaningful, then after the lesson is over, after the worksheet is gone, after the test has been graded, and eventually after the teacher is no longer standing there, the learner should be able to do something they could not reliably do before. That's learning. And once we define it that way, the next question becomes much more interesting. What kinds of educational experiences actually produce it? I'm Dr. Heath, and this is Educated with Dr. Heath.